Introduction. Welcome to this review of Artificial Intelligence and Human Evolution Contextualizing AI in Human History. In the next minute you will hear a brief overall summary, followed by a section-by-section breakdown of the key ideas. Overall summary. We start the journey with the origin of life on Earth and then follow the evolution of life forms all the way reaching up to humans. Around the end of the LHB period, or around 3.8 billion years ago, the Earth started to cool down again. 2. Moderate temperatures on the surface of Earth. If God created life on Earth, what else did God create? Why was life created only on planet Earth and not on any other planets in the solar system? The evolution of eukaryotes is a crucial landmark in the history of life on Earth. Chapter 1. Overview and Background. One of the crucial differences between human intelligence and AI, at least for now, is that AI is totally and completely under the control of humans. AI cannot function without humans turning the power switch on, and AI cannot reproduce itself. As a matter of fact, the topics in this book should be relevant to all the people on planet Earth in one way or another. Then, we look at what makes humans the most dominating species on the planet, even more so than what dinosaurs were hundreds of millions of years ago. We then look at what made humans more intelligent and superior to all the other species on Earth. The scope of changes that took tens or even hundreds of years are likely possible in matter of months and single-digit years with AI, and it definitely makes it much harder to get a realistic perspective on it. I like to take pride in presenting these far-reaching concepts all the way from Darwin's theory of evolution to the rise of machines and human intelligence and its comparison with machine intelligence or AI in a way that makes them accessible to general audience without a single mathematical equation or formula. Joshi Artificial Intelligence and Human Evolution tips //doi.org U10.1007 978-1-4842-9807-7 The notion of artificial intelligence, AI, or just plain intelligence at its deepest level pertains to life. We understand that our Earth is a planet, and it revolves around the Sun along with 7 other planets. This is where we draw a line and separate the living from the non-living, separate intelligent objects from not intelligent objects. In summary, the word intelligence, the way we interpret it at least, is intrinsically linked with the concept of life. Hence, we will start our journey with the notion of life. Even if the very definition of life can be daunting, we are mostly very good at classifying any object as alive or not. So, what is it that separates the life forms from not life forms? The comparison between different versions of philosophical definitions of life can be a topic broad enough to deserve a book in itself. We will rather focus on scientific or logical interpretations of life in this book. One of the most widely accepted explanations of life as worded in various encyclopedias and dictionaries identify life as something that encompasses biological processes and some form of signaling and self-sustenance, capacity of reproduction, energy transformation, and growth. The idea that is trying to be captured here is a list of parameters that can distinguish the living from the non-living. It seems to be hinting at something like a Venn diagram, one where the explanation is trying to draw overlapping circles to isolate everything that we see around us that is living from what we think that is non-living. Let us try to apply this concept to various objects we see around us. We obviously know that all living organisms show growth, but what about some non-living organisms, say rocks? Thus, if we have growth as the single rule to separate living from non-living, it is not sufficient. Let us start adding more of them to the Venn diagram shown in Figure 2.1. Chapter 2. Core Ideas. Once again, we know that all living organisms are capable of consuming some form of energy as required for their life-supporting activities, thereby transforming one form of energy into another. Thus, we can indeed separate them from living things. So these two circles, or rules as shown in Figure 2.2, are not quite sufficient to separate living and non-living, and we need to proceed with one more. Venn diagram with two parameters from the definition of life. Let us add capacity to reproduce, as shown in Figure 2.3. We are quite certain that all the living organisms, from single-celled ones to complex mammals, can reproduce. But similar can be stated in the case of living things also. Let us move outside of Earth and look at some of the bigger celestial objects. How about planets? Heck, how about our own planet Earth, for example? Also, millions of energy transformations are happening continuously on Earth. Seems like Earth can lie at the center of all the circles along with all the living organisms. So, is Earth a living object? Essentially, biological processes are the ways in which an organism's cells work together to support life. Non-living objects without explicitly using the notion of life or biology for that matter. Hence, Earth as its own object does not satisfy this condition. It might appear that this single rule can potentially separate the living from non-living. Thus, we essentially need all the other parameters to distinguish between the living and the dead, but only the first parameter is sufficient to distinguish between the living and the non-living. Now, equipped with the full definition of life and what truly separates the living from the non-living and dead, let us look at the question of how it all started. Did life start on Earth, or did it come to Earth from some other planet, or asteroid, or a star even? Based on the atmospheric and thermal conditions required for most species on Earth, it is rather difficult to imagine a life form coming to Earth from outer space. Let us take a closer look at the option of life on Earth originating from outer space. It is quite clear that all the large species or the species that we can see without needing a microscope cannot survive outside of Earth for longer than a few minutes, if that. It is quite encouraging that these microorganisms can survive in these harsh conditions on Earth, but what about outside of Earth? This cosmic radiation is reduced to only trace amounts on the surface of the Earth due to absorption by Earth's atmosphere and deflection by the Earth's magnetic field. Chapter 3: Key Concepts. Even if we agree with this theory of life's origin outside of Earth, the fact still remains that the species that came to Earth from outer space must have originated somewhere else. So, until we answer the ultimate question of origin of life from non-living substances, the chain of questions does not really end. Let us now look at the other option where life originated entirely from scratch on Earth. Our solar system came into existence around 4.6 billion years ago, when the Sun was first formed. It took another 100 million years for the other planets to form, completing the solar system. These heavy elements clumped together over the next 100 million years to form the first four planets in the forms of Mercury, Venus, Earth, and Mars. This period extended for about 400 million years from 4.5 billion years ago to 4.1 billion years ago. The LHB period started around 4.1 billion years ago and lasted for another 300 million years till about 3.8 billion years ago. Although quite violent, this was an extremely crucial period from the perspective of the origin of life on Earth. These meteorites and comets brought key ingredients to Earth, including water. However, whatever remained was sufficient for the formation of life. There are mixed opinions on exactly when life originated on Earth. As per the early discussion on definition of life, in order to prove that life originated on Earth, we need to prove the creation of biological structures capable of displaying functions such as growth, signaling, reproduction, etc. All the different theories that base the origins of life on Earth on the chemical reactions that naturally happened are referred to as primordial soup theories. As per the RNA world hypothesis theory, the first living microorganisms were entirely based of RNA structures. However, a recent study published in Nature 5 magazine supports the theory that early life that originated on Earth can be entirely based on RNAs. These conditions include 1. Formation of Earth's crust. The water accumulated during the LHB period was sufficient to create oceans covering over 70% of Earth's surface. 5. And last, but not least, the dense atmosphere on the Earth was able to cause heavy lightning. If God or the superior entity did create the life, why did it create from the small microorganisms? Why did it have to go through the long process of evolution? If God created life on Earth, God must have created the solar system also, and extending the argument, the entire universe as well. If God created the entire universe, why did she wait for billions of years to create the Earth and life after creation of the universe? Chapter 4. Deeper Analysis. Life, as we all know it, indeed differs from other concepts in the universe. We take life for granted as we see so many different life forms around us, including us, but at the start, it was far from obvious. But definitely some chemical reactions happened using atoms and molecules that were readily available on Earth that led to the formation of the first biological structure. In the next chapter, we will look at how life progressed through time. Joshi Artificial Intelligence and Human Evolution tips //doi.org 10.1007 978-1-4842-9807-7 Our perception of intelligence is tightly integrated with life and living organisms. In the previous chapter, we looked at various processes that led to the origin of life on Earth in the form of single-celled organisms. In this chapter, we will dive deeper into the topic of life and look at how the life that originated on the Earth culminated into the creation of complex species such as humans containing trillions of cells. The first organisms that were created on Earth were primitive single-celled organisms based on a single RNA or DNA and were capable of carrying out all the fundamental life processes. Transformation of the primitive single-celled organisms into these highly advanced species did not happen in a short time, or by accident. The theory of evolution by natural selection is credited to Charles Darwin. Darwin proposed his theory of biological evolution in the year 1859 AD in his coveted book On the Origin of Species. Having said that, it takes a genius to propose or develop a theory as simple as evolution and be valid and capable of changing our understanding of life on Earth. Newton's theory of gravity and motion, which can now be looked upon as a simplified version or a special case of the general theory of relativity, can answer most questions in real life. In order to move forward with the specific details of human evolution, let us quickly go over to the fundamental principles of Darwin's theory of evolution. Darwin's theory of evolution is based on two steps that take place in a repeated fashion generation after generation in the life cycle of the species: random genetic variation in offsprings by the process of mutation during reproduction, natural selection dictated by survival of the fittest. Let us look at the first aspect of the theory. At the same time, if the offsprings are generated using excessive random variations, the continuity of the species would be lost and whole new species would be created in every generation. The continuous mutations across all species make the habitat a vibrant and dynamic place where mutual interactions between species are changing continuously. The concept of adaptation describes a process of change by which a species becomes better suited to its environment. As a matter of fact, an implicit rule that an organism cannot adapt to its environment in a single generation is at the very heart of Darwinian theory of evolution. Obviously, it takes thousands of years to see these physical changes, and in some cases, they lead to the creation of a whole new species, thereby merging with the process of evolution. The principles of random variation of features in offspring during reproduction and natural selection coupled with adaptation in the Darwin's theory of evolution do provide an architecture that can explain the occurrence of modern humans starting from single-celled organisms about 4 billion years ago, but it does not provide direct explanation of everything that has happened with life in the last 4 billion years. The earliest life forms that appeared on Earth constituted what we call prokaryotes. It has been concluded that in the early formative years of Earth around 4 billion years ago, the atmosphere of Earth was vastly different from its current state. Chapter 5: Conclusions and Takeaways. With natural selection trimming the species that were ill-suited to the environmental conditions, the process kept on going for millions of years. About 500 million years into it, around 3.5 billion years ago, the first cyanobacteria appeared on Earth. The next major step in evolution was the appearance of eukaryotes. The most widely accepted theory is called the endosymbiotic theory. This DNA is similar between them and is separate from the DNA in the nucleus of the host species. Natural selection further allowed eukaryotes to become more successful than prokaryotes, and they eventually became the dominant form of life on Earth. Based on the dating of fossils, eukaryotes are considered to have evolved and prospered around 2.7 to 2.1 billion years ago. The jump from eukaryotes to multicellular organisms is yet another important milestone in the evolution of species. This leaves a huge gap of anywhere from 2.1 billion years to 1.5 billion years, when the Earth was occupied by only single-celled eukaryotes and prokaryotes. As a first step in the evolution of Chlamydomonas, they started to form colonies. To give a comparison, it took more than 1 billion years for the first single-celled prokaryotes to evolve into more sophisticated but still single-celled eukaryotes, while it took less than 400 million years for first multicellular species like sponge to evolve into first rat-like mammals known as Morganeucodon. Then the evolution of mammals like Morganeucodon to primates in the form of Purgatorius or Archicebus took less than 150 million years. The evolution from early primates to first hominin in the form of Sahelanthropus chidensis took less than 60 million years. From first hominins to first of the Homo species, Homo habilis, took less than 5 million years, and from Homo habilis to Homo sapiens or modern humans took only 2.5 million years. This spread is quite phenomenal and absolutely unprecedented in the history of life on Earth. No other species has been able to occupy the regions on Earth with so much diversity in climatic conditions, without spending hundreds of generations of evolution in those regions. Genetic scientists have found evolution of some minor but new traits being developed in humans living in different regions of Earth, but nothing close to the creation of a new species. Over the last 100,000 years or so, the physical appearance of humans has not changed much. As a matter of fact, if humans don't need to evolve to adapt to the changing environment order of magnitude faster, there is no need left for their evolution. Tools can include anything that humans have created using their natural organs, e.g., hands, feet, brain, etc., and leveraging living or non-living things available on Earth. The creation and use of tools marks probably the greatest achievement by humans, that puts them in a completely different league of species. So far, we have discussed the evolution of species from the perspective of Darwin's theory of evolution based on genetic variation and natural selection. As such, it is not hard to poke holes in the theory of evolution. Darwin's theory really kicks in after life has already originated, and as such the two underlying principles that drive the theory cannot explain how life came into existence in the first place. Closing. That brings us to the end of our review of artificial intelligence and human evolution, contextualizing AI in human history. Thank you for listening. If you found this helpful and would like more book summaries like this, please subscribe to the channel and turn on notifications so you never miss a new video. Tell me in the comments which book I should review next, and I will see you in the next one.